All right, well, good morning / afternoon to everybody. This is ARC313. Maybe your first breakout session so far that you've attended at reInvent. How many people this is like, other than the keynote, this is the first thing you've been able to attend as part of your, okay, a couple people, great. Well, thank you for making it all the way to the other side of the conference. If you attended the keynote this morning, you're the expeditious ones, or if you are like staying close by on this end of the strip and knew that you wanted to attend this and you did not attend the keynote in person, you're the ones that have forethought and foresight to make your time efficient. So anyway, thank you for being here. My name is Andrew Baird. I'm a senior principal solutions architect with AWS. I work out of our Atlanta, Georgia office. I've been with AWS for about 13 and a half years, and there has been no stretch of time in my entire career in technology where I have felt as motivated, as disrupted, as excited as now, for sure. And my past time at AWS has been mostly dedicated to developer-oriented things, building systems, DevOps, serverless, our API-oriented services, CI/CD, and the amount of impact and the amount of capability that's been delivered to folks like me and the customers I talked to in the last 18 months is mind-blowing, and hopefully everybody in the room or watching on YouTube kind of that resonates with. And so we're here to talk to you a little bit about, for all the folks that maybe have career histories and trajectories like myself that are software builders, developers, and are coming into the fold of generative AI as it's kind of evolved into quite a bit of focus around agents. What are some ways you can take the skills you've got already and the things you understand and bring it into this new world? So we're going to have the agenda broken out as follows. I'm going to spend the first third of the presentation talking from a perspective from AWS, talking about how to think about and understand agents in the context of service-oriented architectures. As a builder, I'm going to talk about how some of the design principles and the important dimensions of building good distributed systems that are service-oriented really lend themselves well or may have evolved in the world of agentic AI. I'll drop a couple ideas about some services that have existed even before today's keynote announcements that could help you as a builder getting into generative AI. And then I'm joined by Dan DeLauro from WEX, who's going to go much deeper into a particular use case and architecture and approach that they took when building out their first set of agentic systems inside of their organization. So you can hopefully walk away with, at the end of the session, with a lot of deeper understanding and a new level of comfort as a software builder on how you might think about approaching these topics and building agentic systems using a lot of the knowledge you have already, and getting a lot of tangible, credible advice from a team and a person who's walked that walk over the last year or so. So let's jump in. So agents for builders. When we've talked about agents, and maybe others have talked about agents, they're often displayed in a way like this. There's an agent that's doing things that sound really personified. They're observing, they're taking actions, they're learning. And when somebody describes agents to me in this term, in these kind of terms, for me as a technologist, as a practitioner of technology, it feels fuzzy to me, and it makes me feel does that mean the capabilities have become so advanced that there's this software, these models that are living inside of the systems we deploy, and they have the ability to take actions and literally learn in a way that makes everything that I'm used to and the way that we build software feel moot now, and technology has evolved past the point where all of the skills that feel comfortable to me and the knowledge that I've earned until this point is being put at risk in some way. And so it gives me this premise of does that mean service-oriented architectures are dead in some way, that we now have software elements that have superseded the context of how we design distributed systems and the way in which they deliver capabilities. Is this the message now? Is this where we've reached? And so as a technologist, what I like to do in those moments where you feel something is just outside your grasp of understanding, and you want to dig in a little deeper, you want to understand it from a technical perspective, and you dive a layer deeper and you get hands-on. So what is observing and learning, all of those things, they have like technical meaning and why those descriptors are often used for agents. But really, like from a technical perspective, talking to builders in the room and watching the YouTube stream, what is an agent really? In the center of the story, there's these LLMs, which I don't need to describe too much of, but all of the capability that a model brings to the table to do things like reason, to have varying levels of expertise across different domains and industries. There's a way in which we want to like tap that knowledge and reasoning capabilities within the context of some business scenario. So that's still part of that's a central part that I'm comfortable as a software builder. I'm not a data scientist. I'm certainly not an AI researcher. The amount of advanced technology capability that's embedded inside that model, I don't understand it to a deep enough context to like extract it and describe it at a builder perspective, but that's living at the heart of the systems that I'm going to build with agents. Talking to that LLM, we have an agent application. It's usually a container, a Docker container. There's ways in which building that software, and this is maybe what I believe is like one of the biggest advancements over the last 12 months, is having technology companies and developers get a much better understanding at how to integrate with models in a way that let them have a deeper, meaningful impact on different application contexts. And so the SDKs like Strands have made it really easy to build agent applications, those Docker containers that are going to be deployed, that define how the software is going to interact with the LLM. So like how the prompts are structured, how the different turns in conversation are going to occur, how they manage things like interaction with memory and past conversations and integration with tools, which we'll talk about in a second. But all of those like new elements of how to well integrate with an LLM so that you can get application level capability out of that model is packaged for you in a lot of like neat and very abstracted ways that developers are much more comfortable with in SDKs like Strands. So I'm going to draw a box around those two things, this Docker container based deployed application and the LLM. I'm going to call that an agent, and you build those agents in pretty abstracted ways using these SDKs that make it easy. For how like the request and response make it into that agent, we've got a use case, whether it's an agent that's sitting inside some chatbot architecture. More commonly, folks are kind of recognizing that the ability to build like autonomous systems that sit in part of business workflows and data architectures, those inputs and outputs might be the same types of messages and events that you prepackage from other upstream applications and services you have, but there's some notion of like a request making it into the Docker container you built and how that request is going to relate to the prompts that are sent to the LLM that's sitting at the center. That agent application and the SDK used to build it has some mechanism for that agent software to interact with dependencies. Maybe the next biggest advancement that's made building agent applications easier is the emergence of MCP. Just about 12 months ago, this month I think, when that standard was first released and really like matured to the point of being adoptable in an enterprise production landscape. Just maybe 7 months ago, as the authentication story matured a little bit. So now we have like a Docker application, a bunch of like new software capabilities on how to interact with models, but then a pretty standardized way to make requests out to what our dependencies might be. And those dependencies can be software applications, they can be databases, data resources, document repositories, all exposed via like a standard integration protocol in MCP that uses service-oriented mechanisms like folks are used to. There may be other agents that it's interacting with via protocols like A2A. Those MCP servers that you're writing may be the integration mechanism for integrating with those agents too. So we got a couple different options for integrating with agents. And like collectively, you have a story here that feels like a service-oriented architecture, hopefully. We've got Docker containers, we've got integration mechanisms, we've got the ability for like defining dependencies and how they interact with each other and sit in the context of some business use case. To me, that feels like service-oriented architecture. So everybody here should be encouraged, I believe, that the way in which agentic applications are truly being built and developed has tons of symmetry to the same types of systems we've been building for decades. And so I'll talk in a minute about different service-oriented architecture principles that still largely apply. There's a lot of net new patterns that are emerging and technologies. It seems like every week there's new libraries that are going viral and new capabilities that are being announced and launched. And just know that as much as it feels like our heads can spin at the speed of innovation that's occurring right now, software engineers, technology builders have been building muscles at adapting and remaining flexible in the patterns that you're embedding into your designs for years and years and years. And all of those muscles for you all and for the builders, I think, sets us up as an audience to take advantage of these technologies rather than necessarily just be disrupted by them. It sets us up nicely. So take confidence in that premise. And then lastly, don't forget non-functional requirements. So we've seen, as somebody that talks to hundreds of customers throughout the year and what they want to do with agents and how they've been building so far, the amount of technical magic that feels like is occurring as folks build these systems lends itself to being, it's very easy to forget the things like operational excellence and security and resilience are things that don't come for free, that they need to be intentionally built into the designs that you have. And there are a lot of folks that I think would attend a session like this have probably been that voice in the room in the past while building systems that know things like scalability are important to include into the design up front in the design thinking. So all of those tendencies you have as a builder are going to lend themselves to making you really valuable as agent applications are being built and developed. Okay, so let's talk about some design principles. So on these next set of slides, there's going to be kind of an evolution of some principles and terminology that hopefully folks are largely familiar with and how they would apply in an API-based distributed system and the design principles that apply. And then we're going to talk about some new ones that we'll try and explain in a set of terminology that maybe will feel more familiar in the lexicon of building distributed systems, but are new things you need to consider inside of building agentic systems. So here's a set of equivalent design principles, I'm going to say, when you're building agentic systems versus all the distributed systems you've built historically. So loose coupling still totally applies. How you deploy those Docker containers, how you think about the benefits of things like asynchronous processing, of having no shared concerns between systems, being able to scale various aspects of a distributed system independently. The way in which an agentic use case is going to sit inside the architecture, all of those principles still apply in very, very, very much the same way. For modularity, I think this is one where we've seen a tendency to build anti-patterns in the space inside of agents compared to service-oriented architectures. So rather than having agents that are expected to handle a lot of various different tasks and contexts within the same use case, all be built as part of the same set of prompts, systems, instructions that you're going to deliver to a particular use case. The ability to think of agent granularity much in the same way as you think about service granularity as you're building microservices and service-oriented architectures. The same types of trade-offs exist. So if you have a use case where it's very logical how you might break down those tasks along different business logic lines or ownership lines or security, segmentation, the same types of benefits you'd have gotten when building services in that way you'll get from building multi-agent systems in that same way. On the flip side of having modular agents, making the tools that you build reusable. So reusability and having the ability for a REST service satisfy the requirements of many different clients that are integrating with it. You want to build your components of tooling, your MCP servers, with that same kind of mindset in mind, where if you have a retail context and you've got an MCP server that's talking to your order history systems and exposing information about past transactions and orders that have been placed. If you have various different agents within a customer support context and the e-commerce buying context and the fulfillment context, all having their own MCP servers that talk to the same set of eventual backend sources of truth, you're going to find yourself in the same types of lack of consistency and problems that would have emerged in a service-oriented landscape before. So having your tools and MCP servers be built in a reusable way and being built by like the appropriate business line domains that own those topics today. We've seen like more of a pattern emerge where the agents that are being built are often very use case oriented and sit close to the edge of an organization, and they're building MCP tools for themselves that their own agents need, and they're building the proxies between their own agents and the back-end architectures that they need to integrate with. And we find it's much more efficient and scalable over the long term to instead think of the MCP server as like an extension of the service integration mechanism for those sources of truth that different agents are going to integrate with. Okay, discoverability. Just like you'd have service registries and copious documentation about what the different capabilities are of a particular distributed system and service or API, you want agents to have the same type of capability. It should be obvious to anybody who's meant to interact with an agent or part of a technology team that is meant to integrate with an agentic system that you've built, or a developer that's being onboarded into your organization, to have a very clear understanding of what the intended boundaries are for an agent that you've built, right? And the good news is a lot of these things are a little more self-evident when building agents to humans than building APIs in the past. There's a lot of stuff we do in natural language when building agents that make it a little easier to be discoverable. But the same general concept applies, that as you're building agents, the need to maintain like team-wide, department-wide, company-wide catalogs of where those agents are and like what their capabilities are meant to do, how to integrate with them, documentation for them, where the observability points are for them. All of those things apply to agent systems just like you would have when you're building service-oriented architectures. Now let's talk about a few principles that I'm going to say have evolved a little bit, that still like at their core, there's ways in which the knowledge you have about a prior principle in service-oriented design is going to like transition naturally into the new world, but there's a little nuance or a way that some contradiction might have emerged that you need to take into account. The benefits of statelessness in service-oriented design have been well understood for a really long time. The benefits that gives you to resilience and scalability, like deployment safety, having as much statelessness embedded in an architecture as possible was always a practical thing to strive for. But now we know in agent applications, having persistent contextual memory across multi-turn conversations potentially, or use cases within workflows that require multiple turns, having contextual memory be embedded as part of the context window for the agent that's performing the tasks or achieving the goals that you define. This is an important part of getting the most capability as you can out of an agent. So there's elements of the data architecture, the memory in particular, that is going to feel it might feel a little unnatural as like a distributed systems builder coming from the past to be comfortable with the idea that the runtime application of an agent is gonna have a lot of you can think of it as session state, but conversation state and memory be building within the same use case, that the same runtime like infrastructure that's deployed, and that adds a couple different dimensions that you need to be conscious of. It means that as memory gets embedded in these multi-turn conversations, that things like scalability and deployment safety across, like when users are in the middle of having a conversation or work is in the midst of being done, what that means for your use case, the idea if you were going to disrupt a multi-turn conversation in the midst of it happening, and what the user experience is meant to look like while that's happening in real time. Next, let's talk about orchestration versus autonomous coordination. So still, like the idea of building like logical graphs and the types of work that should occur, and understanding what the dependency flow and structure looks like for the architecture you build. Those things were very deterministic and able to be documented and understand at design time in the world of distributed systems, and using capabilities like step functions from us and other like graph-based workflow platforms. But with agents, you have the ability to let the coordination emerge at runtime as the type of like non-deterministic work that you might want to take advantage of it's possible for there to be multiple use cases that a single agent system is going to satisfy, and depending on the type of request that comes in and the context for it, you may have different specialized agents downstream that handle different components of it. So understanding like how coordination is meant to relate to each other and how that coordination is described, and how to allow it to emerge at runtime versus defining it in a very discrete way. And you have trade-offs here you can make. And Dan's portion of the conversation, there may be use cases where you want more determinism in the workflow that you're building, and you don't want a lot of like emerged coordination that's more autonomous and like non-deterministic at a macro level. And you can combine some of the principles here with the principles you know and the patterns you have from service-oriented architecture, like patterns of the past that will still apply. So next, service contracts and capability emergence. It's like has been fundamentally important in like good API design to understand like the concepts of backward compatibility and like client-server relationship at the contract level and what the different data elements were and like the allowed values and like ranges of those values was a key part of what allowed service-oriented architectures to proliferate and be stable. But in the world of agents, capability can emerge at runtime, and that's a benefit of it. The idea that as like tools change and capabilities are deployed, you don't have to update layers of your agentic stack in order to expose those things and expect the agent to like evolve its behavior through coding changes you've made. As those tools, descriptions, and capabilities emerge over time, the agent will discover them at runtime, and it will allow new capability to emerge as tools are built and as they change, and as capabilities are released. Those things can emerge in real time. I'm going to call it totally new design principles that folks need to kind of get comfortable with. Software engineers often joke that a lot of what our career has boiled down to has been building CRUD, building create, read, update, delete, and a million different business contexts. But in the end, if you're talking about business logic, there's some way in which the code you're working on any given day is going to boil down to building some form of CRUD related to some type of business domain object or a technical domain object. And that meant that like helps ground your design thinking and the patterns that you're going to build. And things are very different now. And the way in which you think about like how to prioritize what use cases are a good fit and what models are going to be like practically applied to, you need to like pivot your design thinking to this idea of goals. That goals are like the new unit of technical work being done rather than CRUD. And if you can distill the type of value you want your software system to deliver to your business or your customers in the context of a very succinctly describable goal, there's a good chance that a model will understand the work that you're trying to achieve, and you'll get a better idea of like what data and what context needs to be delivered into that model to achieve the goal. Reasoning transparency. So the whole idea of reasoning as like a deployable piece of technology is fundamentally new on its own, but it means that observability is fundamentally different too. The logs that we used to gather needed to only include a lot of like metadata about the actions that were taken, metadata about those actions, the events that occurred within the sequence of code, so timestamps and like where elements of code were executed. And now there's this non-deterministic ability for software to think inside of your architecture and being able to think about how you want to ingest that observability into an architecture and use it thoughtfully when you have operational reasons to review it or analyze it or debug it. So having a good set of ideas of how reasoning transparency and the evidence of it is part of your operational pipelines and architectures is a key new thing that you need to think about, building other distributed systems to ingest and to process and things like that. Self-correction. There's tons of patterns like circuit breaker and others where error handling and fault handling has been a large portion of what can make distributed systems reliable. Agents have like a general tendency to want to self-correct and find ways to achieve their goal via multiple paths. And there may be times where this is a big benefit for you, and there's other times where you may not want an agent to take advantage of this. So having a very explicit understanding that at build time, at like the definition of the agentic system you're designing and deploying, that this tendency exists inside of the agent you're building, and what it might mean, the different error scenarios are that we'll encounter, whether it be like a tool is unavailable, or like access changes occur that like limit its capability, and how an agent may react to those things, and what would you want its behavior to be in those scenarios, and to take those things into account as you're building your instructions, designing your downstream like dependency architectures, and all of those things is net new work that you should be thinking about as a service-oriented builder. And then lastly, like maybe most fundamentally, is this idea of non-determinism in general, understanding that the type of testing that you're able to do, we just announced this morning, agent core evaluations can play a huge role here. There's ways in which that fundamental premise that the software work being done is going to be non-deterministic is going to change a lot of the typical ways in which you've achieved some operationally related goals for agentic systems compared to how you worked before. Okay, now I'm just going to run through things that hopefully if you're in the session you understand these services are available already, but I've mentioned strands a little bit a couple times already, but AWS's mindset here is like adopt an agent framework in general. Don't feel like you need to write software that's going to integrate with all your models out of the box and in some sophisticated way without taking advantage of the SDKs on the market. And Strands, we think, it was released at a very neat time where the model capabilities and their ability to reason really advanced to the point where it let us build an SDK that hit a really nice sweet spot on making the ability to develop quickly and reach production quickly, like at the appropriate level of abstraction that leans into the model's capabilities to reason without a lot of like design time complexity, but still a ton of robust operational and security benefits that you get from using it too. So choosing the right agent SDK. For like building and authoring the code related to everything I've described so far, we have the Kiro CLI and the Kiro IDE. You have the ability to adopt Cloud Code. You can have your model inference for the cloud models behind Cloud Code get deployed on Bedrock. If you're a team that manages like model governance and access inside your enterprise and you like the Bedrock model of that, you can have Cloud Code be backed by a Bedrock model. And so many of the things, like as software engineers are learning these things, there's new capabilities that are going to help you author the software and produce it for you without you having to get down to that level of detail yourself. And then obviously Bedrock Agent Core Runtime, as you more and more are going to be responsible for understanding like the high level translation between business requirements into like the prompting and code development you're going to do with agentic systems, having an infrastructure platform like Agent Core Runtime that abstracts as much as it can on the infrastructure side in a serverless way and give you a lot of confidence that like the AWS reputation from like operational excellence and security are going to be embedded in that story is going to like help you accelerate and get to production more quickly. And then I just want to call out here that the Agent Core Runtime where the Docker containers get deployed can also be your MCP servers that you build as well. So all the different tools that you might build for your agents, deploying to Agent Core Runtime is a place that those MCP servers can be deployed as well. Okay, so that's all the general kind of overview that I'm going to provide you today. I'm going to pivot over to Dan, and Dan from WEX is going to come up and talk to you about their experience building agents as a company.
Thank you. Dan. Am I on? All right. Good afternoon, everybody. My name is Dan DeLoro. I'm a solutions architect on the cloud engineering team at WEX. And let me change my slide here. There we go. That's the right button. Sorry about that. So last year I was sitting out there, right? And I was in a session just like this, and I was hearing about Bedrock and agentic and all these new tools that make it look really easy to build with AI, but it always kind of felt a little bit out of reach, right? I'm like Andrew, I'm no data scientist. I don't have a background in machine learning, and I'm not building neural networks, but I didn't need any of that. Because honestly, as builders, all of us, right, as people who understand systems and patterns and architecture, we've actually got an advantage. And that's kind of what prepared me for all of that. Like the building part though, like this speaking thing is new. That's a new thing for me, but I'm here. So thanks for coming out. Today, I'd like to talk about how we've been using Bedrock agents and now Agent Core to enrich our operational support at WEX. And I think you'll see a lot of the principles and a lot of the things that Andrew covered They're there, and they're kind of what made that possible for us. And they're really what helped us go from pilot to production in under 3 months. And now we've got well over 2,000 users internally. So it's been a good year. But first, we've got the company slide. In case you don't know who we are, WEX is a global commerce platform. We power mobility, benefits, and payment solutions for organizations in more than 200 countries. We operate one of the world's largest proprietary fleet networks, and we help consumers manage their benefits accounts, things like HSAs and FSAs and LSAs and COBRA. And we handle everything from corporate travel to expense management, all with the goal of simplifying the business of running a business. Last year, we processed over $230 billion in transactions in more than 20 different currencies. So it kind of goes without saying, right? Our platforms need to be reliable, they need to be secure, and they have to run at scale. And that's where Global Technology Services comes in. Now, we're sort of the team behind the teams. We design the shared services that drive platform engineering standards, reliability, governance, cost optimization, all the paved roads that let everybody move really fast without getting into trouble. My team's job at WEX, is to make cloud feel simple, even when it isn't. And last year, Global Technology saw more than 40,000 support requests. Now, that's a lot, right? But if you think about it, every last one of them is critical to somebody, even if they are repetitive and time-consuming for us. And we've got operations, and we've got SRE and support at all of those tiers, but we're always looking for ways to reduce that number without reducing quality. So like everyone else, we started looking at AI. But we didn't want to do anything flashy or complicated. We just wanted to start small and build something simple that would just quietly make our lives easier. And that's what inspired us to build ChatGTS. And in case you don't see what we did there, GTS is just short for Global Technology Services. It's kind of got a ring to it, right? But anyways, I promise, there's more to this than a chatbot story. Sure, it can chat. It lives in our chat. It can read our documentation, and it'll do Q&A all day. But underneath, it's evolving into more of a virtual engineer, one that understands cloud and network and security and operations. But we're not replacing people. We're just doing what we do in operations. We're automating the repetitive stuff, and we're expanding our self-service capabilities. Really, we're just trying to free people up so they can focus on the problems that matter, the ones that actually move the business forward. But we had to start somewhere, right? We didn't want to just build agents because we could, or get stuck in that cycle of chasing shiny objects whenever something new came out. So we looked at our data, our support history, and those 40,000 tickets. And then we asked ourselves, what are we seeing the most, right? Which are the most complex or just flat out painful? Really, where are we spending the most time? And then we looked at the places where we had existing automation or runbooks or some kind of a process that people were already executing. And we realized that was the sweet spot. That high volume, high friction, well understood work, that's where we knew we could make a dent with AI. I brought 2 examples to share today. But keep in mind, we did start with chat, and we focused on Q&A so that we could build up our knowledge base. And we saw immediately, instead of opening a ticket just to find information, people were able to come and find it on their own. And we were building agents that could leverage that knowledge base to make their own decisions. So that was sort of like setting the foundation and laying the platform for all of this. But now, this first example is honestly my least favorite ticket. And hopefully some of you will understand why when we get to it. But the second one is a little more exciting because we're moving beyond chat and we're embracing event-driven design with Agent Core. But together, I think they show how AI can really become a part of operations, not a side project, but more like a teammate who's always on call. So can anybody relate to this? Has anyone ever had a network issue they've had to troubleshoot? Well, I know you do, right? Well, consider yourself lucky, because at WEX, we operate hundreds of AWS accounts. And we've got Azure and Google, all spanning 8 regions and multiple on-prem data centers, and it's all interconnected. Now, you probably know there's a lot of tech that goes into making that possible. So when something inevitably fails, it can be challenging. Even with the right tools, it's hard. So picture this. almost noon, you're getting ready to go to lunch, and you get a ping in your support chat, and it's Jared from the PaaS engineering team. And he's like, dude, we're blocked. We're trying to deploy this cluster, and we're in this new VPC, and we're expecting it to reach all these things. Now, Jared doesn't have access to the transit gateways or the firewalls or the VPNs, and even if he did, maybe it's a little out of his wheelhouse, but that's not his job, right? You know that feeling. You like Jared, you don't want to leave him hanging, but you want to go to lunch. Now, it's like you don't have a choice. You have to respond. Well, now you don't, because we built an agent that can respond for you. And now what used to require all this tribal knowledge across all these different domains, it can happen in minutes, and anyone can use it now, even Jared. Now, in this example, it's an EKS cluster, and the agent knows it's an AWS, and it can go into our core network account, and it can use reachability analyzer, so it provisions a network analysis path. Now, we know that takes a while, so while that's running, it fans out and it checks flow logs, it looks at any recent changes in the network, and then it looks to see if there's any known issues, right? There could be something already happening. But by the time it's done, it's collected all of this information from all of the things it's looked into, and it breaks it down in natural language and presents it to you as the end user in chat. And it shows you exactly where that traffic dropped and why. So now, when Jared needs to escalate, he can do it with the right team and all of the right information. And since we're logging all of these investigations, we're able to spot recurring issues. And maybe we identify opportunities for some tighter guardrails in the network. But at the end of the day, this is a perfect example of how an agentic system can scale maybe where humans can't. Now, the second one is my current favorite because, like I said, this was more than a chatbot. Now, we're building agents that are responding to alerts and anomalies, and they're understanding the state of a system before they're deciding how to react. They're not just hanging out waiting for a ping. And honestly, this is the best kind of AI because you don't even realize you're using it. Now, we all love EKS, right? Containers, they're gonna solve all our problems and, it's gonna save the world. But they're not always the answer. Now, don't judge, but at WEX, we've still got some critical workloads that just make more sense running on EC2, but we still have to support them. So picture this. You've got an EBS spike out of nowhere. Your CloudWatch lights up and you can almost smell the smoke, right? Now, this could be a warning shot, but why chance it if we can get in front of it? But if that workload matters, someone's getting a page. Somebody's got to wake up. They got to log in. Then they got to figure out what's happening, where is it happening. They're checking logs. Maybe they're running playbooks to expand the volume, or maybe they're just hopping on and clearing some space. Whatever they're doing, that takes time. And let's be honest, nobody wants to do that at 2 a.m. I certainly don't. And that's one of the reasons we built this. But it's the reality today. So now we can flip the script a little bit. Let's take a sip of this real quick. All right, so instead of paging an engineer, we can send these alerts to an agent with all of those metrics and context. So now we're not calling anybody. We're not waking anyone up. That's no longer that first line of defense. The agent can see what's happening, where it's happening, and it can find an agent or a team of agents to help with the issue. Now, our first agent does some discovery. This is like triage. It looks at the operating system, it looks at the version, it looks to see which platform it belongs to, it looks to see how critical it is. And then it looks at history. It looks to see, has this happened before? How many times have we expanded the volume here? We maintain policies to cap expansion, right? You don't want to just keep adding disk, you're kicking the can down the road, that's never going to work. So at this point, if anything looks off, the agent steps out of the way, and we escalate back to a human, and then we're back to the way we do it now. But if not, our agent can connect into Jira through Agent Core Gateway, and it can open a ticket and start logging the incident. Now think about it. This analysis is huge because you're collecting all of the inputs you're going to need a week later if it evolves to an incident and you need to craft an RCA document. So now that we know what's happening, it passes on to our maintenance agent. And this agent can choose from a library of pre-existing SSM documents. Now keep in mind, these are the same documents that our ops engineers are using at 2 a.m. We've got playbooks to run diagnostics and backup and cleanup and expansion. It's all the usual runbooks, but we've exposed them as tools to the agent on an MCP server. So now, whatever the agent decides to do, it's using the same automations that we already trust. And we're not waking somebody up to push that run button. We've eliminated the chats, the texts, the pages, the cross-team escalations. And now these systems they're starting to learn how to take care of each other. And as they learn, they're building memory. And over time, they can start to recognize patterns. Now we can learn where we're cleaning up on occasion, where we have to escalate. And maybe they start to spot issues at the application layer. Now, that's what makes this feel less like automation and more like a team that just gets smarter over time. And once the issue is resolved, we can update Jira through Agent Core Gateway, and then we can publish status to SNS through an MCP server. And from here, we can notify engineers, on-call systems, dashboards, whatever else is downstream from there. But we're not done yet. This same agent is going to follow that resource all the way upstream, back to the Terraform or the CloudFormation or whoever or whatever built it in the first place. And it's going to open a pull request, or it's going to create a Jira issue, or send an email. It's going to do something that closes that loop between operations and infrastructure so we can remediate that drift we introduced in the incident. Now, I'm going to be honest, I've been doing this a long time. I've seen some cool stuff, but when I see stuff like this work, for real, like the first couple of times, I still kind of feel like a little kid. It feels like magic, right? And I just hope it sparks some ideas and inspires, to see what's possible when you think about applying AI to operations. I know this is a basic example, we're just expanding a volume here, but we're just getting started. This is us learning how to use what we already know, and we're reusing what already works. It's not magic, it's just engineering and architecture, and that's kind of the point. So I'm gonna zoom out, I'm gonna talk a little bit about how we got there, and then we can look at some diagrams, we'll see what it looks like under the hood. So when we started this, we knew we wanted to build more than a chatbot and a RAG pipeline, right? We wanted to create a platform. We wanted something sustainable, something extensible, something that would inspire all of the other teams to come and collaborate and help us expand this, because operations takes a village. But we didn't have to change the way we built things. We just had to let these old patterns breathe a little bit. It was all the same stuff. We built agents with boundaries. We gave them clear responsibilities, and we let them all work independently. And we saw guardrails become the contracts for what those agents could and couldn't do. And events, it became less about something happened and more about here's what happened, here's what it means, here's what we can do, and here's what we did the last time it happened. And of course, observability, right? We still need to see everything, but there's more to this than 200s and 500s now. We're looking at behavior and reasoning. There's nothing new, though. It all translates, and it all still makes sense. So here's what it looks like. Out of the gate, I'll be honest, it was a little challenging because at WEX, we don't use Slack, we don't use Teams, we use Google Chat, and there's no native integration between Google and AWS for collaboration. So on the left, right, we have our users chatting with us in our workspace domain. Now those requests come over the internet. So in the middle, we have our WAF with Imperva that secures our inbound traffic. And on the right, we have our AWS environment fronted by API Gateway. And from there, we use a Lambda to route and acknowledge messages, and then we use step functions to orchestrate all of our agents. We store state and conversations in Dynamo. Reasoning traces land in S3. And of course, Bedrock hosts our agents and knowledge. So on paper, it looks pretty simple. It's neat, it's easy, it's serverless, it's exactly what we wanted. Now our chat application is only assigned to the users who are allowed to use it. And all of those messages come with a signed token that we can validate. And then it hits our router. And here, we can filter out noise, oversized prompts, and we can send a quick response to that user, basically saying, hey, we got it, we're working on it. And that helps sort of absorb the model latency because agents still take a while to do their work. But really, at the front, at the edge, this is just a clean, well-defined contract for everything else downstream. And it keeps our front door predictable. Now, I'll admit, before this, I never really did much with step functions. I know they're on all the exams and everybody has to learn them, but I always felt like they were just for people who built too many lambdas. But it turns out they're actually perfect for AI. Bedrock gave us the intelligence, the parts that can think and create and make decisions. Step functions gave us the discipline we needed to keep it all in check. We used the retries and fallbacks and state transitions. And that's where it really clicked. Like Andrew said, these agents, they can be autonomous, but they don't have to be. You can give them as much freedom or as much control as you need to. And that's what made them fit so well in these operational workflows. So Google gives us a trusted identity, but it has no concept of permissions. That token really only tells us that you're allowed to talk to us. So we take that identity, and we reach out to Active Directory and we fetch your entitlements and cache them in Dynamo. Kept it pretty simple. It's all based on group memberships and OUs. And that way, we're not beating up on systems that were never really meant for real-time traffic. So basically, Google tells us who you are. This is how we figure out what you're allowed to do and how far you can go before you ever reach an agent. And when we invoke that agent, we wrap the entire prompt in context tags, and we include your identity and your entitlements and send that downstream to the agent. So now, whatever the user claims, the agent only trusts that context because it's immutable. And here, if something goes sideways, say the agent fails or times out or can't produce a response, we log the error and we can send a safe response back to the user without blowing up the whole workflow. Now, once the agent responds, we want to capture everything. We store messages in Dynamo and traces in S3. And from there, we format the response so it looks good in chat. Google has their own markdown language, and that allows us to include citations and reference links and any attachments that came back. And then we update that temporary message we sent from the router. And that takes what feels like a request response, and it turns it into more of a transaction. It's more like an actual conversation, and that's kind of the point. So really, that's how step functions helped us. It gave us this structure where there was so much potential for chaos. And it's all the same patterns, right? There's retries and fallbacks and circuit breakers, and it's baked into every state transition. That helped us hold all of these creative parts accountable. And now we can observe it, and we can measure it, just like any other workflow. So when it came to agents, we were inspired by SOA, right? Think about what it taught us to break up the monolith, right? We took these big systems and we turned them into smaller pieces with a clear purpose. That same discipline applies to agents. And we built specialized agents and gave them one job that they have to do really well. And that keeps the focus really clean and the reasoning sharp. And then the handoffs between agents is even cleaner. But instead of having one giant orchestrator pulling all of the strings, ours acts more like a conductor. It sits in the middle. It can interpret intent, and then it can figure out what's happening, where's it happening, and then it connects that problem to the right expert or the right team of experts. But even experts need boundaries. With all this autonomy, we needed to have guardrails. We needed some way that we could enforce policy and compliance. So we apply guardrails at the edge with the orchestrator, and this gives us defense in depth for every decision that happens in the platform. Now we're sanitizing text, we're blocking topics and redacting PII both on the way in and on the way out. So now the guardrails, they're not just protecting our data, they're actually protecting the agents from themselves. So they can wander, right? But they still can't color outside of the lines. But none of this works unless they're all operating on this same source of truth. And that's where shared knowledge comes in. Now, all of our agents tap into the same knowledge base. So that means when we have a Q&A agent answering a question about connectivity, it's pulling from the same material an ops agent would if it were troubleshooting. They're separate services, but it's consistent understanding. It's like giving every application in your service layer this unified data plane. Only now, it's made up of runbooks and reference architectures and living documentation. But thinking isn't enough, right? At some point, we got to let the agents do something. But they act just like any other service on the network. They're calling APIs, MCP servers. They're executing the tools we've given them to do their jobs. So with Bedrock action groups, we can run these lambdas inside of our VPCs with tightly scoped permissions, and then we can control what they can reach and what they can't reach. And at the end of the day, it's just services talking to services, just like any other application layer on the network. So how do we define that truth, right? Documentation, of course. And ironically, that was the hardest part of all this, because at the enterprise, you know it can live anywhere. And even when people can find it, they don't like to read it, but they'll chat with it, that's for sure. So we wanted to build something that could grow and evolve with the organization, and we needed something more than just a dumping ground for files in S3. So we chose Kendra with the Gen AI index because it gives us this hybrid. We get keyword and vector search with multimodal embeddings. And with all of the built-in connectors for things like Confluence and GitHub and Google Drive, we're able to keep all of our information in sync automatically with cron schedules. Now, it includes source code and diagrams and policies and runbooks. It's like all of our domain expertise finally lives in this one searchable layer. And the best part about that is it actually comes to us. We don't have to chase it down anymore. We don't have to find the documentation. The real breakthrough wasn't just building a knowledge base. It was figuring out how are we going to manage this thing, right? So those data sources for Kendra, they're configured in Terraform, and they live in GitHub, and we deploy them with CI/CD. So with self-service, we allow the people who own that content, the subject matter experts, to maintain it themselves. They can open a pull request, and we can deploy their changes through GitOps pipelines. Now, it's still enterprise knowledge. We're just treating it like infrastructure now. I'm not going to lie, observability was a bit of a puzzle. Like, we have this third-party chat up on the front end, this hybrid identity between Google and Active Directory. Then we had lambdas and step functions and Bedrock agents. It started to feel like we had metrics coming at us from every direction. So we had to find a way to stitch it all together so we could actually see what was happening. So we built this persistence layer in Dynamo. And this is where we store the things we care about long-term. This is all of our users, their chat spaces, their sessions, all of their messages. But it's not a transcript. This is relationships, because every item here keys back to a session and a trace ID. And those traces land in S3. And this became our black box. This is like the flight recorder that captures every decision that's made across the platform. I mean, it's basically distributed tracing, right? But instead of following a request, we're following a train of thought. And of course, we needed transparency. So we pushed all of our logs into Splunk through Kinesis. And now, even info security and compliance and risk and legal, they've all got a real-time view of what's happening in the platform. They can see what people are saying. They can see what the agents are saying. They can see all of the redactions, all of the policies being enforced. And at the end of the day, everyone's happy. Now, I'm going to say this like it was 10 years ago because it feels like it, but it was only 4 or 5 weeks. But back when we started, there was no agent core. There was no built-in observability. But we still needed a way to understand what was happening. So we got together and we built this dashboard that produces some practical insights. And of course, when I say we, I mean me and my team and Cursor and Claude and Copilot, but all my smartest friends helped out. But literally with this dashboard, we can replay a conversation step by step. And then we can see the story sort of unfold. We can see what people are asking for. We can see where the agents are struggling. And we can see where maybe our knowledge base needs some work. But this kind of visibility doesn't just measure quality, it shapes it. This is what drives our roadmap. This is what tells us what we need to build next. I'm almost done, I promise. It's my last one, then everybody can go. This was a big year for AI. I mean, all the new models, all the new services, the tools, all the new acronyms that we're secretly Googling on the side, and I hope I'm not the only one who has to do that. But honestly, I've never had more fun learning and building at the same time, and I feel really lucky that I get to work with this stuff because it's awesome. It just is. I learned a lot this year, but there's 3 lessons I'm going to carry into next year that I want to share with you. Number 1, the architecture still matters, right? It's all the same diagrams. There's new services and there's new icons, but you don't need to be a data scientist to piece it all together. I feel like I'm living proof of that. And second, you don't have to build a platform. You can start small, but think big. Build something simple that will teach you what to build next. And of course, please breathe, right? Go outside, touch some grass. Maybe wait till you get home. There's not a lot of grass in Vegas. But seriously, it's way too easy to get wrapped up in all this tech, right? We still have a say in this. Don't let it overtake you, because you could blink, and the next thing you know, you're in Vegas on the stage and you're explaining what you did last year, because that could happen, trust me. Thank you. This was awesome.
Thanks, Dan. Thank you, everybody. Hope you enjoy the rest of the conference. Remember, if this is your first one, we've got surveys that come out. It really helps us and gives us the ability to speak in the future, especially if you enjoy the session here. So have fun this week. Stay safe. Enjoy the party on Thursday. And thanks again.